Good morning, everyone. Thank you for joining us for today's live demo of ThreatX's next-gen WAF. My name is Mackenzie, and I will be kicking us off today. So just a little bit of background on why we host this, why we have this series. So, enterprises are expanding their businesses with more web-based and cloud-hosted apps. While, really this has enabled many businesses to grow, it has also increased the sophistication and frequency of attacks that threaten enterprise data. This has introduced a real challenge for admins and security teams to stay up to date on the latest attacks and ultimately protection measures. So the founders of ThreatX they experienced these challenges firsthand and took what they liked about legacy solutions and combined those features with a new approach to web application security that helps to minimize some of those burdens felt by security teams. So today's session, kind of a continuation of the session last week should really give you more information on that approach. So a few quick housekeeping items just before we dive in. All attendee lines are muted. That being said, we are going to do a Q&A session at the end. So if you have questions for Kelly, you can submit them using your GoToWebinar control panel. You will also receive a link to the on-demand recording of this demo within 24 hours, so definitely be on the lookout for that. And at the end of the presentation, we will share contact information for you to get in touch with the team directly should you have further questions or want to schedule a personal demo. And now I'm going to hand it over for our speaker for today, Kelly Brazil. Kelly?
All right, thank you, Mackenzie. Appreciate that. So let's go ahead and get started. And what we're going to talk about today is, why do we need next generation WAF? And then we'll go through some of the features of that and then give a quick demo of what it's all about. So sounds good. Let's get started. So one of the main issues that we've run into, and when I talk to customers all around the world, there's definitely a consistent theme, and that is that their existing WAF is failing them. A lot of times the biggest complaint is that there's just a huge administrative burden to using a WAF and keeping up with the constant tuning. And also it's very difficult to onboard new applications because of that tuning exercise. It usually takes about 2 to 4 weeks. I've actually talked to customers who have said that it's taken 12 months or longer to get an application tuned on their legacy app because they use static signature-based approaches. And then the traditional WAFs are really more designed for traditional web applications, but then when you start getting into the world of APIs and microservice architectures, then they begin to kind of break down there as well. So we'll talk about how you can protect APIs and things like that. So what ends up happening is that there are lots of organizations that have a WAF, but they don't really end up using it to its full potential. So for instance, maybe an organization that has a WAF, they might only protect a handful of their applications just because of the administrative burden of adding more and more applications. Or what we tend to see is a lot of organizations will have a WAF and then it'll be in line, but it won't be in blocking mode. It's just basically providing visibility. So it's not really working as it's intended, and in many cases just generates more work for the security team because they get a lot of alerts coming in that has to be filtered through a SIM, and then there has to be investigations whenever they see high-level alerts, which more often than not tend to turn out to be false positives. So there's a lot of downsides to the existing WAF technology, and so basically we'll talk about a next generation approach and how we can fix these things. So like we talked about, one of the main issues with the legacy WAF is that they rely on static signatures, right? So you kind of have this this dichotomy or this paradox with signatures where you can have very generic signatures or you can have very precise and specific signatures. And there's pros and cons to both, right? So the idea is that if you have very precise signatures, very specific, then you might get less false positives and false negatives because you basically are really tuning those signatures for a specific a specific type of application or a specific type of threat, right? So, typically a WAF might have hundreds of thousands or millions of these, but since they're so specific, you might get many false negatives because you're missing kind of more broad type of um, threats, maybe new threats that no one has seen before. So then the thought is, okay, well, let's make the signatures more generic, right? So that you're not necessarily looking for a specific threat, but maybe you're looking for just a general vulnerability or something like that. Well, when you make the signatures too broad, then it mistakes just normal user actions for threats, and then you get into this, too many false positives. So you get into this kind of tuning cycle where you're trying to keep the signatures from being too precise and too generic. So you're kind of in the happy medium of false negatives versus false positives. And oh, by the way, this is specific to every application. So there's no single rule set that's going to be perfect for one application versus another. So it's become unmanageable. Back in the old days when there was just a few thousand rules, maybe it was manageable, but now there's hundreds of thousands, even millions of rules that are built, and the new ones are coming out daily, so it's just become a management nightmare. So what we've done at ThreatX is we've redefined the WAF, and so we call this next generation WAF. So if you think about next generation, the idea is that with a generational change, you're not just tinkering around the edges, you're basically rethinking the whole problem. And what that means is that the whole industry is going to be moving in this direction, the next few years. In fact, the way that we're doing this is already kind of the way that the rest of the industry has moved, right? So if you think about antivirus, it moved from static signatures to a behavior-based type of approach. The same thing is true now for network security. Things are moving away from signatures and into a behavior-based models. And so we've done the exact same thing for the WAF, is we've moved away from signature-specific approaches and moving towards behavior-based approach. So the idea here is that instead of having to have very specific signatures or overly broad signatures looking for different indicators of compromise, we're actually looking for tactics, tools, and procedures, or TTPs, of the attackers. So what that means is we don't need to manage hundreds of thousands of rules anymore. We basically can manage these kind of known threat activities. But what that means is that now, if you're doing it that way, you have to keep state. So a traditional WAF doesn't really keep much state. It just basically looks at every web request and says, oh, this is a good request or this is a bad request. And it needs to make that decision within a split second. When you're doing a behavioral-based approach, you actually want to keep a lot of state and save a lot of context. And so in our case, what we do is we keep 3 months worth of state or context. And so when we make a block or allow decision, it's not based on just that one single web request that we're seeing. It's based on months of data that we've stored and built into our risk model for that particular what we call entity. So when we talk about next generation, we want to make sure that we're going beyond talking about just anomalies. That's kind of been a buzzword in the past few years, but anomalies do not necessarily translate to threats, right? So what tends to happen is if you're just looking for anomalies, basically it puts more work on your plate, because now it's your job to go back to your SIM and investigate that anomaly and see whether it's a threat or not. So we go to the next step of actually identifying these fundamental attacker actions, keeping state on them, and then building a risk model over time for each entity. And then even more than that, we can actually actively engage the entity. So what that means is in real time, we can actually send cookies or code down to the user of the application to fingerprint the user, or to track the user as they hop around IP addresses, or maybe see if the user is a part of a botnet, right? So gathering more intel of the user in real time. We can also deceive the user, so send fake information down. So if the user trips on any of these fake tripwires, these deceptive tripwires, then that's also intel that helps influence the risk score. And we can also do things like slow down the attacker. So if they're doing a layer 7 DOS attack, or if there's a specific API call that you want to protect, or a login page, things like that, we can slow them down. So the idea is that there's a lot of non-blocking actions that you can take. And then finally, the solution has to be cloud native. So not only supporting the legacy applications that are in legacy data centers, but also handling APIs and new microservice architectures like Kubernetes and things like that. So it basically future-proofs the solution. It allows you to have a consistent policy across clouds. So if you have multi-cloud environments, it should be very easy to install and drop into these architectures, so you don't have to do something crazy like a transit VPC to funnel traffic in unnatural ways. So you want to keep on good terms with your DevOps team, and then and also keep in step with your DevOps practices like your CI/CD pipeline. So one of the Achilles heels of the traditional web application firewall is onboarding new apps takes too long, and then as the applications change, then you get stuck in this tuning cycle, and that just doesn't work with when you have a CI/CD pipeline where you're deploying new code every week or sometimes every day. So what we do at ThreatX is we actually have a profiling service that learns the app within 24 hours, and then after that, we're continuing to learn the app for any new changes. So just within minutes, we can see any new changes to the app and update our behavior rules based on that. So what that means to you is that we can basically onboard, several or dozens or hundreds. We have customers with thousands of applications very quickly, because now you can onboard an application into blocking mode within 24 hours instead of the traditional 4 weeks or longer. And then as the application changes, you don't have to go back and tune it. It just happens automatically. So there's a lot of benefits to the next generation approach as opposed to the traditional approach. We talked about a risk model a little bit, so you can kind of think of it as a kill chain. You might also think of it as a MITRE attack framework, but we'll just talk about the kill chain here because it's kind of easy to conceptualize. But basically, what we do is we keep a state for the attackers over time. So 90 days of state, and we're basically building this risk score by looking at their behaviors, not necessarily indicators of compromise, but looking at their actual tactics and procedures. And as we see those things, we increase their risk score based on different fuzzy logic algorithms that we have built into the system. And so what's interesting is that if you just kind of look at a typical kill chain here, on the left-hand side, you typically have the lower level type of things that aren't gonna break the application or expose private data. And then of course on the right-hand side, you have more of the advanced attacks and exploits that are actually gonna break the application and expose data that these types of things need to be blocked right away. With a traditional WAF, you tend to just throw away all the information on the left-hand side because you're tuning it, you're trying to get rid of all the noise. And then, if you just log all these types of things, the reconnaissance and port scanning and application mapping, that's just too much noise and creates too much work for your team. So what we do at ThreatX is we basically will keep that information. We're keeping all these breadcrumbs of what that particular user is doing, and we basically use that to inform the risk model for that user. And so if we start to see a lot of threat activity, maybe it's a low and slow attack that's happening over multiple days or weeks, eventually that risk score will get high enough to where that entity should be investigated or will automatically be blocked. So kind of interesting that basically instead of throwing that information away and instead of creating more work for you, ThreatX is basically silently keeping that information, basically applying risk models to the entities based on that information. And then we have all that evidence behind us. So if the entity escalates up the kill chain later on, and we do a block, you actually see all of the information, all the breadcrumbs behind why we made that decision. So the idea is that we're not a black box just making decisions that you can't figure out why we made the decisions. We're acting more like a security analyst and showing you everything that led up to that block. So it's really nice. So finally, let's talk about deployment a little bit here. So typically you'll have your applications are on-prem, or maybe they're hosted in a cloud like AWS, Azure, Google Cloud, or whatever. They might even be container-based like Kubernetes or something like that. It doesn't matter where they're hosted. So the idea is that you have your users on the internet, and you might already have a CDN provider. But ThreatX has a global cloud. ThreatX also can act as a CDN as well. And so what we have are these WAF sensor containers. So we are container-based, Docker container-based. And so that means that we can deploy on anything, whether it's bare metal hardware, virtual instances, Kubernetes, it doesn't matter. And the idea is that you can deploy these sensors on-prem or in your cloud environments if you want to, and you can be as close to the application as you want. Some customers like very low latency. Some customers want to integrate the sensor containers into their Kubernetes, maybe do a sidecar pattern type of design, things like that. So these are all possible. But actually what's the most popular type of deployment is for ThreatX to actually deploy the containers within our cloud. And that's nice because now we're basically taking on the responsibility of the sensor deployment, the scaling, the high availability, all of that, upgrades, we're handling all of that for you. It almost becomes like a managed service at that point. And so we'll, geographically disperse the sensors in very, high capacity data centers with peering, very fast peering connectivity to all the major providers. So this provides a really nice option for customers to just very rapidly get applications up and running without having to mess with load balancers and things like that. So very popular deployment option here. And so you get the traffic to us just by changing a DNS entry. It's just a CNAME change for the application, and then all of a sudden the users are connecting to the closest sensor container that we have deployed for them, or you can also do this via your load balancer configuration here. So once the traffic is getting to these sensor containers and it's being scrubbed before it's being sent to the applications for any of these threats, this is where we're doing all those things we talked about. We're first profiling the application to learn the application. That's usually a 24-hour cycle before we go into blocking mode. We are profiling all the behaviors of the attackers. So basically getting all this metadata and all their behaviors and learning those so we can keep building a risk model. And then all of the other things that we do, the active response, the deception, the tarp hitting, the IP fingerprinting and all that. We're very API friendly, so we look all the way down into the XML or the JSON, or even down into WebSockets, which is very unique to us as well. So a lot of kind of modern type of applications can be covered at a deeper level than you would with a traditional WAF. And then of course you can do your own custom rules and caching and things like that. So if you have some business logic rules you want to add in there, it's very easy to do so. So all of this security analytics capabilities are happening on the sensor containers themselves. But what's nice is we're also doing higher level analytics within our cloud. So basically what we're doing is we're taking metadata about the attackers and we're running it through what we call our HackerMind behavior analysis engine. And what that does is it gives us both cross-site and cross-customer correlation. So that's nice because the traditional WAF is just kind of sees its own view of the world. Whereas what we do at ThreatX is we basically are sharing information across all the sensors. So if there's an attacker that's attacking one of your sites, all of your other sites get protected automatically. And that also applies across customers. So all of our customers get inoculated when we see things that are happening. And then we're putting in third-party intel into the system automatically and curating that for you. So as the security industry gets smarter, we just ingest that data and we make sure it's high quality. So you don't have to worry about handling that. We're doing that cross-customer analysis. And we also have a 24/7 SOC that is doing threat hunting on all of this data. So that's kind of interesting because a lot of organizations have barely enough resources just to get their WAF up and running and tuned, much less do any threat hunting on that data. So it's kind of a nice thing that ThreatX customers have, is because you get a second set of eyes looking at your data, and we have that layer 7 expertise to basically let you know if we're seeing something that needs your attention. Our SOC has research analysts that are very skilled, and so you might check out our blog. We release information regularly about new threats that have been found. Just recently, we uncovered a large proxy infrastructure that was being used by bad actors, including botnets. So they're doing a lot of great research there to protect not only our customers, but the industry at large. And finally, everything is built on top of a RESTful JSON API as far as the management. So you don't go into these sensor containers and manage them individually. That's kind of an old school way of doing things. We have one single management platform that's in the cloud, and basically it's very easy to spin up new sites, get information, get logs, things like that. So everything's very easy to orchestrate. It's very extensible. And on top of that is our dashboard UI, our CLI, and of course you just open tickets with our SOC if you have any questions on how to configure something, or if you want them to configure something for you. It's very easy just to open a ticket and have them, our SOC, handle that for you. All right, so now I'm going to go ahead and jump into a demo and show you around a little bit, and then after that we'll have a Q&A session. Okay, let me go ahead and log in here. Get my two-factor going on. All right, so what we're looking at here is the dashboard UI. You can kind of see, all the different activity happening on the various sites that you might have protected. This is a demo, set of demo sites that we have. So there's a lot of red going on here. So traditionally, your sites won't look like this, hopefully, but this will kind of demonstrate what we're talking about with entities and all that. So you can see, at this point in time, all of the users of the site were of medium or low risk, and then at this point in time, one or more entities is a very high risk. So we take a very a viewpoint of what are the entities or users of the site doing, and so we build that risk model that we talked about. So you can see we build a risk score of 1 to 100. So it's very easy to understand. 100 is high risk, and then 0 is low risk. We also track the intensity. So is the user scraping or scripting against the site more aggressively than other users? So that also goes into the risk scoring model. We give every user or entity a name. And this is interesting because the entity name is automatically generated. It's a pirate name. It's an adjective and a pirate name concatenated together. But what's really cool about this name is that it's shared across customers. And so what that means is that allows our SOC to do that cross-customer correlation. So if you have a question about a particular entity that is, doing something suspicious, you can always open a ticket with our SOC, and then they will, check to see, do we have any more information about this entity? Is it doing something across a certain vertical, or is it a botnet or something like that? You'll notice that entities have IP addresses associated with them. But entities can have more than one IP. So if I scroll down here, I'll probably find one. There's one. Well, Yisu Spider. So you can see this one actually has a well-known name. Yisu Spider is a publicly known name for a botnet. So we will change the name of entities after they've been automatically generated to something that's well known if we can identify that bot or whatever it is. But as you can see, we track multiple IPs within an entity as well. So this is really nice because you don't have to do this correlation yourself in your SIM. All of these behaviors from all these IP addresses are being correlated together. And so we'll take a look at what that looks like. So now you can kind of see the red, the yellow, and the green. Entities in the green here we're tracking because they may not have even done anything bad at this point. They may just have something suspicious about them. Maybe their user agent string is a little bit off. Maybe they're coming in from a Tor exit node or an anonymizing proxy. Maybe their IP reputation is bad. So even though they haven't done anything, we want to just track them so that we have all those breadcrumbs for later. In the yellow zone is where we're starting to see tactics and procedures that look like application mapping or scanning, reconnaissance type of stuff. This is where a traditional WAF are going to throw this information away because it's just too noisy. It doesn't add a lot of value. But in a next generation WAF like ThreatX, this actually does provide value because now we're correlating all this information with an entity and we're keeping all these breadcrumbs because maybe 2 days or 2 weeks from now, this entity does more egregious stuff, or they keep doing this stuff over and over again until finally it's time to block that entity. So we're keeping state here. What's also interesting about this area is that this is where we're doing the non-blocking actions. So we could be fingerprinting or tracking these entities across IPs. We could be deceiving, so sending fake information down. We could be tar pitting, so slowing them down as well. So this is where you'll see a lot of that non-blocking activity happening. And then finally in the red zone, this is where you're very close to or already at a blocking threshold. So we'll do per request blocks if they're very egregious OS pop 10 like SQL injection or cross-site scripting type of things. We'll block within the individual request. Or if they're more of the slow and low type of things, then the risk score comes into play and we'll start blocking based on the entity score. So what I'll do is I'm going to dive into an entity here. And let's see if I can find, let's just look at that Yisu spider that popped up here. And what's kind of nice about this one is that there's a bunch of activity. We've been tracking this one since early February. There's a lot of IP addresses in here. You can see right now it's blacklisted, but I could go in and whitelist it. I could also do this through the API. And I can kind of see an overview. There's 860 matches going on here, but I can see that there's a lot of different attack states going on. There's reconnaissance, there's some web app mapping, and then there's also some exploits that happened. The responsive actions, there was a lot of temporary blocks. Now this is a demo, so we keep unblocking this particular attacker, but in the real world, what you would see is 3 temporary blocks, and then we go into a permanent block state. So you wouldn't necessarily see this in your environment, but again, this is a demo. And you can add notes. So this is great for your SOC analyst to be able to say, hey, we're tracking this particular entity, and so it allows you to kind of communicate among the team and keep information in there. So what I want to do though is I want to go into this detailed view, and this is a great view because this basically shows activity over time and the volume of activity, and also the severity of the activity. So I can kind of see this. This is a bot that does some scraping, and occasionally it'll do some kind of SQL injection or cross-site scripting. So the risk score kind of goes up and down over time. Typically if it was more of a bad actor, you would kind of see more of the risk score just kind of going up gradually over time. But this, bots act a little bit weird, but again, we keep unblocking it, so it keeps coming back for more. So here you can kind of see we've been tracking some behaviors. So there's been these blue, the darker the blue, the more severe the action that's happening. And then you can kind of see that the risk score goes up and down based on those activities. And so down below is kind of nice because this is where it really saves you a lot of work. I'm going to show 100 rows here, because now you don't have to go back to your SIM to be able to pull all this information together. You can basically see all the individual matches that are going on. You can see whenever we do a risk update, so we're either reducing or increasing the risk level. And then you can also see where there's individual blocks happening at the request level. And then occasionally you might see in here, let's see if I can find one, you might be able to see an entity block. So probably on one of the other pages, I could see an actual entity block here. So the idea that's kind of nice is that you can also see we're tracking multiple IP addresses here. So again, we're doing that cross IP correlation. And you can see every behavior has a risk associated with it, and that risk is what actually goes into influencing the risk score for the entity. So what's kind of nice here is I can see a few requests that got blocked immediately because it looked like they were SQL injection, and I can go ahead and open those and get more detail, and I can actually see, you know, where that happened and what the parameters were. So I can see this looks like a classic SQL injection. One of the things I didn't mention is that we use a SQL analyzer. So for our low-level OWASP top 10 type of stuff, you know, one of the things that's interesting is that we believe that OWASP top 10 protections, that's kind of like the lowest basic thing. Any WAF should be able to do that at very high quality. We do that plus, you know, higher level type of attacks, botnet type of attacks. So we're actually doing, you know, a lot more than a traditional WAF. But what's interesting about this is that a traditional WAF would look at these parameters and run a bunch of regular expression type of signatures over it to figure out whether this was SQL code or a cross-site scripting attack or something like that. What we do instead is we have semantic analyzers that actually tokenizes this input, and it looks to see whether this is actual runnable SQL code or cross-site scripting tags and things like that. So let me see if I can find something that's interesting here. So, you know, the word query, right? So a lot of times, you know, you might get false positives, and this is one of the issues with traditional WAF is because you might have a field where a user is just putting the word query into a comment field or something like that. Well, that could be suspicious because query is also a SQL, could be, well, this is actually part of the argument here. Drop table would actually be more of the example here. So maybe you have the words drop and table in a comment. So those would be part of the SQL commands. But if someone's just talking about a table and they dropped it accidentally, that would be a false positive. But what we're doing is we're actually taking this whole string here, tokenizing it, and running it through a semantic analyzer to see if that is real SQL code that would run. And so that's when the SQL injection detection happens. And so this is this provides very low false positives, very high quality, because we're not just looking for signatures, we're actually looking to see if this is runnable SQL code. So that's another way that we provide very low false positives. So this is basically it for entities. The nice thing here is that you're seeing, you know, all this bad activity. You can very simply see, you know, where the directory traversal is happening and which ones are blocked immediately and when an entity is getting blocked. So you might not even have to go down to this level. You can see all the entities that we're tracking and all their user agents. But this is nice when you do want to dive in, and it saves hours of investigation, because now you can very easily see, okay, it makes sense to block this entity because it's doing bad stuff. Or if it's a false positive, you can very quickly go ahead and whitelist the entity and maybe go back and, you know, write a rule to tune it or have our SOC tune it. So it's very easy. And one final thing I'll just kind of show is that you can add your own rules. So maybe if you have your own business logic rules and things like that, it's very easy to go into different aspects of the web request, all the way down into the body, all the way down to the XML and the JSON. If you're protecting APIs and any request versus response direction. And you can just create nested ands and ors. So it's a very powerful rule building engine, very easy to use. And you know, you have a lot of granularity, so you can create, you know, whatever risk you want for that particular behavior. So if you want to track those behaviors, or you want to just block outright or slow them down, or if you want to send down, you know, IP fingerprinting interrogation actions, So we're adding more and more of these actions as we go. So a very powerful engine there. So that is the overview of ThreatX and our entity-based risk modeling approach. And so what I'll do now is I'll hand it back over to Mackenzie so we can do some question and answer here.
Awesome. Thanks, Kelly. Yeah, we have about 10 minutes for questions, and we do have a few coming in. So if you have not submitted a question, you still have time to do so. The first question we have here is, for false positives, how is whitelisting achieved if it's required?
Yeah, that's a good question. So it's very easy. Like I mentioned before, everything is API based. So you can automate whitelisting through our API, or you can just manually do the whitelisting through the UI, where you go into the entity that you see is got a false positive, and then you just basically drop down from blocked or blacklisted to whitelist. And then that gives you some time to kind of investigate, why that entity got blacklisted. The way that we work is kind of interesting. Traditional WAF, when you get a false positive, it tends to affect a lot of users, almost, basically all users of the application at the same time. So it's a very bad situation to be in when you have a false positive with a traditional WAF. With next generation WAF like ThreatX, since we're entity based, it's nice because when you get a false positive, which you always get false positives from time to time, but they're very rare. They only tend to affect a single user, right? So you don't have a whole kind of application-wide outage, and you have to figure it out. You basically are dealing with a single user that is maybe doing something outside the norm. So a good example would be our SQL analyzers are looking for real SQL code. Sometimes we'll be protecting, say, like a Jira ticketing application. And so we will actually see developers that are actually putting real SQL code into their Jira tickets. And then, of course, the SQL analyzer will flag on those. So those are things that you can easily whitelist via the entity level, or just through what we call whitelisting rules, so that basically is a more permanent way of whitelisting that.
Awesome. Kind of along a similar vein, and I think you've touched on this a handful of times, but we'll just reiterate it here. Does a next-gen WAF prohibit me completely from leveraging signatures?
Yeah, that actually is a good question. Signatures, as we talked about, have their disadvantages, but sometimes it does make sense to use a signature. So we haven't completely gotten rid of signatures. They are still available. They basically are our behavior rules, but our behavior rules can be written as signatures if you want to. And occasionally our SOC will do that if there's a well-known threat, say like an Apache struts or something like that. Not only will we rely on the behavior rules, which are nice because they give you that zero-day coverage, they actually stop the behaviors that lead up to that particular threat or known vulnerability, but we'll also write a signature for that vulnerability as well. So we don't do it for every single CVE exploit and known to man, because we don't want to be managing millions of signatures. But occasionally, as it makes sense, we will do that. And of course, as a customer, you can do that on your own as well.
Awesome. Thanks, Kelly. Another question here. We already have a WAF in place, and it's embedded within our security operations. So can ThreatX coexist with what we already have?
Sure. Yeah, absolutely. We can go in, traditionally we start out in non-blocking mode, either in front of or behind the existing WAF. And a lot of times that's just to see what the existing WAF is missing, right? So whether it's higher level botnet attacks, or activities that are being correlated across IP addresses or sites and things like that. So we'll go in front of or behind the existing WAF. And then we can start blocking whenever appropriate. So they can work together, but what tends to happen is that after a certain amount of time, you find that a next generation WAF is much more effective, and so you just tend to phase out the traditional WAF. There is also a sniffer mode where we can be deployed off a span or a tap port. And so that's interesting because then we're out of band. And so some organizations will start out in that mode just to kind of get visibility before moving inline and replacing their existing WAF.
Thanks, Kelly. I know we have a number of customers that are in blocking mode, but this question here is, I've never put my WAF into blocking mode. How is ThreatX different?
Yeah, well, so ThreatX is very different because basically, 100% of our customers are in blocking mode. We don't kind of ascribe to that way of thinking that a WAF should not be in blocking mode. It would be like having your regular firewall in non-blocking mode. It's just the WAF is not doing its job. It should be blocking threats proactively. And there's just too many threats coming in today for security teams to have to go in and manually make blocking decisions after the fact. By that time, it's too late. So the only way you can go into blocking mode is to have a very accurate blocking, and that's what a next generation WAF provides. Is that it's very common for people to not put their WAF into blocking mode with a traditional WAF because they just don't trust it, and WAF has traditionally had a bad reputation when it comes to false positives. Whereas next generation WAF that's using a behavior-based approach like ThreatX is very accurate. And after that 24-hour learning period, all of our customers go into blocking mode. That's just the way it works.
Awesome. Thank you, Kelly. It looks like we have one more question here. How much integration do you have to have with the development team?
So that's actually really a good question because we are technology agnostic. We don't, we use reverse proxy technology, which is, tried and true, very fast. It allows us to do a lot of things, not only inspect traffic, but also inject code and things like that. So the reverse proxy approach means that we don't actually have to care about how the developers are developing the application. We don't have to care about what version of web server it is or what version of libraries they're using, right? So you can be very independent from the application development team, which is nice because now you don't have to, basically get too much into their processes. So that's great. But then you have some teams that are the other side of the coin where they actually do want to integrate into their CI/CD pipeline. So we do make that possible because we're basically very agile. And so since the WAF, the next generation WAF, is learning the application very quickly, you can be very DevOps friendly and integrate with any DevOps practices. You don't necessarily have to integrate with the application developer team in the sense of using libraries and specific versions and all that, but you can very nicely integrate with them. But that being said, you don't have to do a whole lot of integration to get things working. And because it's reverse proxy based, you don't have to deploy agents or anything like that on the web server or libraries or anything like that. So it's very easy to deploy without tight integration with the developer team.
Fantastic, Kelly. That's great. That is all the questions that we have time for today, but I do want to share just those few couple things that you can do if you want to take some next steps. Always reach out to us. We have that email listed right there. Contact us with any questions that you have. Our team's always willing to talk one-on-one with you about your security challenges and kind of get a free trial POC kind of set up for you guys. So definitely feel free to reach out. And as I mentioned earlier, we will send a link to the replay here. So you can kind of share that with your colleagues here. Look out for that in the next 24 hours. Thank you for your time today. And thanks again, Kelly, as always.
Thank you.